All right, everyone. There was a couple of questions this week about for loops in Matlab. And what I wanted to do is just write a quick video here for you so you can follow along and see what for loops are all about. So for loops in Matlab are actually really important because they allow you to repeat a series of commands or computations for a specific number of times. And this word here, for, I've bolded because it says for a specific number of times. And this is what computers are really good at. Computers are really good at repeating a computation over and over and over again, which would be monotonous for a human, but really great for a computer to do for you. So let's start off with something simple. Let's say you wanted to say hello equal to 1 10 times. So to do this, we're going to look at the syntax for a for loop. A for loop will do for. This is telling the computer to do this for this many times. So for I is equal to 1 colon 10. So if you just wrote 1 colon 10 out, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A for loop is going to loop over all of those numbers. And it's going to start off with for I equals 1. Go to the next line and do whatever's here next. It's going to say hello equals 1. And it sees the end of the loop and it goes back up here and it says for I equals the next number, which is 2, hello equals 1, end. Goes up to the next one for I equals 3, hello equals 1, end. It's going to keep on going until I equals 10. It's going to go hello 1, end. And it's going to go back up here and it's going to say, is I 11 possible? And it's going to say, no, it's not, because I goes from 1 to 10. So it's going to stop and it's going to continue on with the remaining code underneath. So let's take a look in Matlab how this looks. So we said for I equals 1 colon 10, hello equals 1, end. And let's just do the following. Let's CLC, clear all, and close all. So let's take a look at what happens when we run this. So we run it, and we're going to say this is our for loops script example. And what you can see is when we run this, it's going to print out hello a bunch of times on the screen, as it shows here. And let's go back to our slides here now. So we've seen we can print hello onto the screen a bunch of times. And what we could do is we could count the number of times, and it should be 10 times that it's printed on the screen. Let's go a little bit further on this. And let's say instead of printing out hello equals 1 10 times, why don't we print out hello equals I 10 times? This will make it easier for us to count the number of times we've done this. So what's going to happen is we're going to say for I, our variable I is equal to 1. Hello is going to equal to I because I is going to be put in the container for hello. So it's going to be 1 is equal to hello, end. Go to the next portion up here. It's going to go I equals 2. So inside of here it's going to say 2 is going to be assigned to the word hello, end. Then 3 is going to be assigned to hello. Then 4 is going to be assigned to hello, etc., etc., etc. So let's see if this works. So in our MATLAB script here, I'm just going to change hello is equal to I. And I'm going to hit run. And what I can see is that hello now goes from 1 to 2 to 3, 4, 5, 6, 7, 8, 9, 10. So this is doing exactly what we think it should be doing. So one of the really important operations and powerful operations MATLAB allows you to use is to calculate things recursively or continuously. So let's say, for example, we wanted to add all the numbers beginning at 1 and ending at 10. So I'm going to write this using this notation here. So summation from I equals 1 to I equals 10 of I, which basically means what I'm doing is I'm saying when I is equal to 1, I put a 1 here, and I add on to that when I is equal to 2, I add on to that when I is equal to 3, when I is equal to 4, all the way up to 10. So in this case here, what this symbol basically represents, I equals 1 to 10 of I, is just the sum of all values between 1 and 10 of this value I, or whatever's inside of that summation symbol. So in order to do this, what I'm going to do is I'm going to write a Matlab code, and unfortunately my PowerPoint slides here got cut off a little bit, but I'm going to start off with the idea that I want to add something to the previous something that I have. So if I take a 1 here, what I want to do is I want to add a 2 to it. So I say 1 plus 2. Then I want to add a 3 to it when I do my loop next. So I'm going to say the previous value is going to get added to the new value that I'm producing here. So let's take a look in Matlab. So we're going to use the word sum as part of that. So we're going to start off here by saying sum. So whatever sum it is that we want to calculate is equal to 0. And then what we're going to do is we're going to say sum is equal to not I, but the I value plus what we previously had for our summation value. And we're going to say pause here so that we can see what's happening each time. So the idea is this, is we start off, we clear everything, we close everything, we set sum equal to 0. And that's basically us saying, let's initialize this variable at a value of 0. Then when we come in our for loop, it's going to go for I equals 1 to 10, sum equals sum plus I. In this case, I is equal to 1. Sum currently is equal to 0. So we're going to get 1 plus 0 equals 1. And then we're going to stop. Then we're going to cycle back through again, and we're going to say I is equal to 2. So when I is equal to 2, this is going to be 2, plus sum, and sum has a value of 1 currently, which will mean this should equal 3. We're going to go through again, and then we're going to get to 3 here. And I is equal to 3, and it's going to be added to the current value of sum, which is 3, which is going to be 3 plus 3 equals 6. We're going to go through again one more time, and we're going to get to I equals 4, and sum equals 6. So 6 plus 4 equals 10, and you're getting the picture. It's just going to keep on going until we hit 10. So let's give this a try and see what happens. So we get sum equals 0, equals 1. Then it equals 1 plus 2, which is 3. Equals 3 plus 3, which is 6. Equals 6 plus 4, which is 10. Equals 10 plus 5, which is 15. Plus 6 equals 21. Plus 7 equals 28. Plus 8 equals 36. Plus 9 equals 45. Plus 10 equals 55. And when I press enter one more time, it ends the loop, and sum ends up being 55. So in this case, what we've done is we've created a series here, a sum series, where we add 1 to 2 through 3 all the way up to 10, and we got the number equals 55. So let's try this last one here, which is a little bit more complicated. This is going to help you with your homework questions 6 and 7, I believe. Basically, in a computer or a calculator, what I want to know is how do they calculate the exponential of x, or e to the x. And in this case, what we're going to try is x equals 10, so e to the 10. Something got messed up in my exponents here. So from math, what we get is we get the summation of x to the n divided by n factorial is equal to, when summed together from n equals 0 to infinity, it equals e to the x. So this is a math derivation that we've had. This is the expression right here, somewhat complicated looking, but all it means is we're going to add together every time we change n, we're going to put that new n value in here, and we're going to add it to all the previous values. So in this case, when we have n equals 0, we have x to the 0 divided by 0 factorial, plus x to the 1 divided by 1 factorial, plus x to the 2 divided by 2 factorial, plus x to the 3 divided by 3 factorial, x to the n divided by n factorial. So in Matlab, how does this work? We're going to start by setting exponent sum is equal to 0. So let's actually go and try and do this. So I'm going to take the previous code I wrote, and I'm going to just change it here to exp sum. So the exponent sum, exp sum, exp sum, and exp sum. And what I want to do is I want to calculate that exponent when x is equal to 10. And my expression for that exponent is x to the n over n factorial. So we're going to do exp sum is equal to x to the n divided by factorial n. And I'm going to change, instead of I from 1 to 10, n is going to go from 1 to 10. We're going to hit run. And what we see is exp sum is equal to 10, 60. Wow, it's growing to a big number here. So the final number we got was this one here, 1.28 times 10 to the 4. Let's see what exp to the 10 it actually is. So it's actually 2.2 times 10 to the 4. So we're going to add some more numbers to this here. So we're going to go from 1 to 100. We're going to take off the pause now, and we're going to see what happens. So when we do this, we actually get a large number of exp sums here. And we're going to compare the final answer to exp of 10. And what we can see is that the current answer, exp minus exp sum, it's something that's 2,000 in size, but it's accurate to the first 3 digits. So you can see here 2.02, 2.202, 2.202. The next number is a 5 and a 6. So we get out of shape right there. We could make, hold on. Let's make it from 0 to 100. That might be a little better, because that's what it was before. And let's see what it is now. Sorry, so it's 10 to the negative 12 difference. I made a little bit of a mistake there. So n goes from 0 in our slides to n. So let's just take a quick look. From 0 to infinity. And I'm going from 0 to 100. X to the n divided by n factorial. So what does this do? I'm just going to go through the code one last time here. We cleared all, closed all, cleared the screen. We set up a variable called exp sum because we're going to be adding things to it. We're going to start off with that value being 0. We then set our x value to whatever the x value is in the equation that we want to calculate. So in this case, we wanted to take e to the 10. And our expression basically says, in order to calculate e to the 10, what you need to do is you need to say 10 to the n divided by n factorial is equal to 10 to the 0 divided by 0 factorial plus 10 to the 1 divided by 1 factorial plus 10 to the 2 divided by 2 factorial. So we get x is equal to 10. Then we do a loop here where we go from 0 to 100 and we add each time a new value, x to the n divided by factorial n, to the previous values. So what we're doing here is we're saying this is our new value, let's add it to our previous summation. This is our new value, let's add it to our previous summation. This is our new value here, let's add it to this previous summation of 2 values. The next one here would be added to the 3 values before it, which is the previous summation. So hopefully this has made some sense. This has allowed us to calculate, in this example, exp to the 10th power using a series sum. Inside of your computer, there are similar expressions whenever you type something in Matlab, like a sine or a cosine. Matlab actually has to calculate it based on summation of values, just like we've done in this particular example. So I'm going to post this particular code, or I'm going to send it out via email so that you can all see it. I'm going to send out the link to the video, which you hopefully have seen now because you're watching the video. And hopefully this makes the homework a little bit easier to do.